Hi everyone. So in the previous video I told you FCFS suffers from convoy effect. So what is convoy effect? Convoy effect says that whenever a process with high burst time is processed by the CPU, then all other process which will scheduled after him will start. Okay, so the high burst time process will require more CPU time, and definitely all other process will have to wait longer to come to get their chance for the CPU. Okay, this is the convoy effect. Now let's take an example and try to understand what exactly convoy effect says that. So let's say we have three process. So here I will give the process number, then their arrival time 80, and then their burst time BT. Okay, so let's assume we have three process P1, process P2, process P3. Okay, and their arrival time is 0, 1, 1, and let's say burst time is 20, 2, 1. Okay, now we have to find the average waiting time of this three process, and similarly I will take another example in which the same three process P1, process P1, process P2, process P3 are running, but their arrival time is changed. So here 22, 1, and here arrival time is 0, 1, 1. Okay, sorry, 1, 0, 0, 1, 0, 0. Okay, so you see that the process P1 is having high burst time 20, and here also P1 is having high burst time 20, but it will come after the process P2 and P3 in the second example, but here in this example it will come first. So definitely it will serve first and it will take more time. So process P2 and P3 will start, and here process P2 and P3 will come first, but therefore it will not start. It will, and the chance of getting their CPU will be high. Okay, so let's solve this two examples. First I will draw the Gantt chart. Okay, so in Gantt chart there are three processes, so try to finish it quickly. Let's say process P1, because it arrives first, so I have to allocate the CPU to process P1 first. And how much time process P1 require? Process P1 require 20 units of time, so 0 plus 20 is 20. Now the next process is process P2. How much time it requires? It requires 2 units of time. Whenever the two or more process have same arrival time, then you will pick the process with lower ID, process with lower ID. So here process P2 have lower ID and process P3 have higher ID. So we will pick process P2. Process P2 will require 2 units of time, so 20 plus 2 is 22. Now the last process is process P3. Process P3 require 1 unit of time, 22 plus 1 is 23. Okay, now I have to find the completion time. Completion time is process P3 completed at time 23, process P2 completed at time 22, and process P1 completed at time 20. So you will see the difference. Process P2 come at time 1 and it requires burst time 2, but it will be completed at the time 22, which is very huge. So here the difference is very much large, and similarly here the difference is also very much large. So let's find the turnaround time also, turnaround time, and thereafter we will find the waiting time. So turnaround time will be completion time minus arrival time. 20 minus 0 is 20, 22 minus 1 is 21, 23 minus 1 is 22. Similarly, waiting time is turnaround time minus burst time. 20 minus 20 is 0. Process P1 will not have to wait because it will starting from the itself it will serve to the CPU. Similarly, process P2 term waiting time is 21 minus turnaround time minus burst time. 21 minus 2 is, which is 19, and 22 minus 1 is 21. So let's add this waiting time and find out the average waiting time. Average waiting time is 0 plus 19 plus 21 divided by how many processes are there? There are total 3 processes. So we have to divide it by 3. Okay. So what is the average waiting time? 21 plus 19 is 40. Yes, it is 40 divided by 3. So here the average waiting time comes to 40 by 3. Now let's take this example. So first we will try to prepare the Gantt chart. Okay. So starting from 0, which process will come at time 0? Process P2 and process P3. We will pick process P2 because their ID is lower than process P3. So process P2 serve first and it required 2 units of time, so 0 plus 2 is 2. Now after that process P2, we will pick process P3. Why? At time 2 process P3 also come and process P1 also come. But why we will pick process P3? Because P3 come at time 0. Okay. Wherever process P1 come at time 1. So based on the arrival time, process P3 will get chance first. And process P3 require 1 unit of time. 2 plus 1 is 3. And the last process is now P1. P1 require 20 units of time. 3 plus 20 is 23. So completion time here, process P1 completed at 23, process P2 completed at time 2 and process P3 completed at time 3. Turnaround time is waiting completion time minus arrival time. 23 minus 1 is 22, 2 minus 0 is 2, 3 minus 0 is 3. Similarly, waiting time is turnaround time minus burst time. 22 minus 20 is 2, 2 minus 2 is 0, 3 minus 1 is 2. Okay, so here average waiting time is 2 plus 0 plus 2 divided by the number of process. Number of process is 3, so it is 4 by 3. So you see the difference. Here average waiting time is 40 by 3 and here average waiting time is 4 by 3. So based on this example, we can clearly say that the FCFS first comes first serve is suffering from the convoy effect. Okay, so this is not the best algorithm. Yes, we can use this algorithm in the early days, but now there are very much other efficient CPU scheduling algorithms available. Okay, so in the next video we will see the next CPU scheduling algorithm, which is shortest job first.